Greetings and welcome to another Math 104 lecture. Today what we will be discussing is just further ideas on quadratic equations and how to solve them. So as a quick refresher, in the past lecture what we did was we looked at two methods to solve quadratic equations. The first was factoring, right? And in factoring, essentially you were doing the same steps that you would normally with factoring. The only difference is that because it's part of an equation, once you got it in standard form, one side was equal to 0. We use that zero product property to say, okay, we have our two factors. We're going to split them up individually to equal 0. And then as a result, we got two solutions. Well, at max, two solutions for doing so, right? Then our second method was we would be considering squares, right? The square root method. And we saw that there was technically two ideas that were very closely tied, bundled together under the idea of the square root method. Just taking, for example, if we had x plus 4 squared minus 2 is equal to 0. You had two different ways of attacking this when you were considering square roots. You could either apply difference of squares once one of the sides was equal to 0, which in this case it is, right? So you could apply difference of squares directly to this. Or what you could do is you could add your constant to the other side, and you can have x plus 4 squared is equal to 2, and then you would say, oh, okay, well, now I just want to attack each operation that's tied to my variable, and in this case, that's the exponent and the adding of 4. So to undo both of those, you would take the square root first. Taking the square root would lead you to a plus or minus on the right side, right? Plus or minus square root of 2, because you can't ignore that negative value, otherwise you're losing a solution. And then you would just subtract 4 from both sides, and you would have two different solutions, right? So that was our two methods of attacking quadratic equations. Today what we're going to look at is we're going to look at two stronger versions of these. So the first is called completing the square, and the second is called the quadratic formula. With completing the square, there is a very particular way that we need to go about things. There's like a very particular set of steps, but once you get the steps down, it's substantially easier than doing considering squares and whatnot. Mainly because this is going to work for a lot of other quadratic equations, whereas you were kind of limited to things in this form, right? You were limited to things in like the x plus, I'll call it h squared plus c. If it was in this form, you were good to go, right? If you had your variable that you cared about, which was x, plus some other number, and it was being squared, and then you were adding a constant to it, then you were good to go. But obviously, not every quadratic is going to look like that. In fact, most quadratics will come in standard form. And what is standard form? Once again, standard form is going to be ax squared plus bx plus c is equal to 0. So this is standard form. And this is what we needed to do the factoring method. This is actually also what we need to do the completing the squares method. The second method that we're going to look at today, and the last method that we're going to look at in total for quadratic equations, is called the quadratic formula. And the quadratic formula is, if we're equating this to tools and their relative level of strength, the quadratic formula is by far the strongest tool that you will have in your arsenal for solving quadratic equations. In fact, if you plug in correctly, the quadratic formula will solve any quadratic equation that you present it with, as long as, once again, you meet the criteria of this guy, right? And the criteria is a can't be 0, because if a is 0, then you don't have a quadratic, right? You just have a linear equation, because then you would just have bx plus c. So as long as a is not 0, you could apply the quadratic formula, and it's going to spit out an answer. So that is by far the strongest tool, but completing the square definitely has its place in our course here, because completing the square is a tool that we're going to need later on when we're talking about circles and equations of circles. And there's really no better way to get, circles into a standard form without completing the square. And we'll see that later on, but just keep in mind that completing the square isn't going to go away, so you do need to know it, okay? So what is completing the square? Well, the best way to really talk about what we're doing is by showing you an example. So let's take, for example, x squared plus 10x plus 8 is equal to 0. Now, your intuition might say, okay, it's in standard form. The first thing that I want to do is I want to try to factor this, right? And so to factor, our coefficient of x squared is 1, right? So we don't need to do that a times c step. And even if you did, 1 times 8 is still just 8. So we're still looking at the same factor pairs anyway. So looking at the factor pairs of positive 8, we know that we're going to have plus or minus 1, plus or minus 8. Remember, the signs are going to match because we have a positive 8. So positive, positive, and negative times negative would still give you positive 8. And then plus or minus 2, plus or minus 4, right? So those are our factor pairs. And we can off the bat cross off all our negatives, all of our negative possibilities, because we're trying to get a positive 10x, right? That's our goal. They have to add together to give us a plus 10x. So our negative ones are out. But then we say to ourselves, well, wait, positive 2 and positive 4, there's no way those are going to work because that's going to give us 6. And even plus 1 and plus 8 still aren't going to work either. It's going to get us close. It's going to get us to 9, but we need a 10. So by our normal factoring method, we would be stuck. We can't progress any further. X squared plus 10x, that might look like a 16 to some people. Let me just fix it. There we go. Plus 10x plus 8 is equal to 0 is not solvable by our first method. And this definitely wouldn't be solvable in its current form by our second method either, right? The considering squares, because we can't, there's nothing here that looks like that we can, take the difference of squares. We don't have it in that form right now. So what we have to do is we have to complete the square. What does that mean? Well, to complete the square, we need to consider the tool. And unfortunately, there's nothing better than I can tell you for this other than you have to memorize it. Whenever you think complete the square, you have to think of this tool, this little expression here. And the tool is b over 2 squared. Okay, b divided by 2 squared. What is your b? Well, b is referencing in, standard form, ax squared plus bx plus c is equal to 0. b is going to be your coefficient to your x to the first power. So in this case, b is going to be 10, right? So why are we doing this? Well, I'll show you guys in just a second, but first let's just focus on computing this, right? So b over 2 squared. Well, b over 2 squared, we just said b is 10. So this is 10 divided by 2 squared. It's the same thing as 5 squared, which is 5 times 5 is 25, right? So we get positive 25. And now this is a good time to stop and say, well, what happens if we had a negative 10? And if we had a negative 10, luckily, this tool accounts for that. It would make sure that we still get the same result anyway. Because what ends up happening? If we had a negative 10, we would have negative 10 divided by 2, which would give us a negative 5. But negative 5 squared is the same thing as 5 squared, right? Because a negative times a negative would cancel the negatives. We would just end up with 5 squared anyway, and that would just be 25 regardless. So in that hypothetical scenario where we had a negative 10x for our middle term, that's totally okay. You will still be doing b over 2 squared, and you will still end up with the same number anyway, which is 25, okay? So what are we doing with this 25? Well, the idea is we took b divided by 2 squared because we want to take the result that we got and add it to both sides of the equation, okay? So what I'm going to do is I'm going to say, okay, x squared plus 10x, and now I'm going to actually put my 25 closer to my x squared and 10x for a very particular reason. So plus 25. And this 25, again, is coming from our b over 2 squared that we just computed, okay? Now, the plus 8 isn't going anywhere off the bat, right? We're just going to carry it down, plus 8. And now it's very important that you do not combine your 25 and your 8. For a very particular reason, right? And whatever we did to the left, we also do to the right. So since we added 25 to the left, we're also adding 25 to the right. As a little note, if it helps you to remember to not combine your constant that you started with, so in this case 8, with the constant that you're adding in, so in this case 25, you can go ahead and you can subtract 8 first before doing this, because we're actually going to end up doing that in this step anyway. So if you subtracted 8 before you did b over 2 squared and added that in, totally acceptable, and that's, totally okay to do it. I just don't do it that way because this is how I was taught. But it won't affect anything if you subtract 8 before or after. So now I'm going to subtract the 8. I'm going to move the 8 over to the other side. And we're going to have x squared plus 10x plus 25. And again, subtracting 8 from both sides, 25 minus 8 gives me 17. And we might be wondering, okay, why did we add the 25? Why do we have a 17 now on the right-hand side? Well, it's no longer in standard form, right? Because standard form is where we would have, a 0 on the right side, on either side, and then, our quadratic expression on the other side of the equation. But what we notice is now we have a different number. We have a different C, right? Our C is now 25. And this is perfect because now we have a second chance essentially at factoring. So now we're going to do the same thing, right? We're going to look at ourselves and we're going to say, okay, is our coefficient to x squared 1? It is perfect. We can continue because, we don't have to do that a times c step. Okay, now we have 25 and we're considering factors of 25 such that they're going to add together to give us 10. And we look and we say, oh, well, this is super easy, right? Positive 5 and positive 5. So when we factor this, we get x plus 5 times x plus 5 is equal to 17. And we can actually do one better here and say, well, we have the same term multiplied against itself twice. So this is really x plus 5 squared is equal to 17. And now we look and we say, wait, now this is actually in the form that we can apply either the difference of squares or just, considering the squares in general, right? So what you could do is you could move the 17 over and you would end up with, hypothetically, you'd end up with x plus 5 squared minus 17 is equal to 0. And then you could apply difference of squares here and you'd be good to go, right? I'm going to do the other method just because it's going to take a little less time. So doing the other method, I see that I have a square. I want to undo that square, so I'm going to take the square root of both sides. So taking the square root, that means that our square and the square root are going to cancel on the left. We have x plus 5 on the left, and we have plus or minus square root of 17. Don't forget the plus or minus, right? When we take the square root or any even root, when we're solving for a variable, you cannot forget your plus or minus or else you will lose out on solutions, okay? Well, now this is really easy, right? And we know how to do this. All we have left to do is solve for x. We have to isolate x. So we have an addition of 5. So now we're just going to subtract 5. Subtracting 5, we get x is equal to minus 5 plus or minus square root of 17. And we're done, right? We have two solutions. We have square root of 5. I'm sorry, negative 5. Wow, I was saying square root. My mistake. Negative 5 plus the square root of 17. And also negative 5 minus the square root of 17. So we have two different solutions here. So once again, just to recap, our idea was we started with x squared plus 10x plus 8 is equal to 0. Great. Okay. We can't factor it. We tried. So what we're doing by completing the square is we use our tool here to complete the square, which is b over 2 squared. Our b term is our coefficient of our middle term, so in this case 10. We found out that 10 over 2 squared is the same thing as 25. We added 25 to both sides because whatever you do to one side, you also have to do to the other. And since we moved over our other constant, we now just had x squared plus 10x plus 25, which was substantially easier to factor than x squared plus 10x plus 8, right? And you might be wondering, well, where is this coming from? Why did this work? Where is this b over 2 squared coming from? Well, this is actually hearkening back to the two of the three popular cases that I really told you to hammer into your memory, right? The first one and the most important one is difference of squares, but these are going to be the other two. And the other two are a plus b squared and a minus b squared. And we know that the only difference between the two is going to be the sign, right? And all the sign impacts is going to be the middle term. So for this one, we get a squared plus 2ab plus b squared. Again, the plus is because we have a plus in our parentheses, before we expanded. And over here, we have a squared minus 2ab plus b squared. Have the hiccups. Once again, the negative is coming out of the negative that we have between a minus b in that parentheses there, okay? So it's the same sign dependent on what situation you have, right? And now we look and we say, oh, wait. We have, what did we end up with? We ended up with, at this piece right here, we ended up with x plus 5 squared, right? And that is essentially this guy. a plus b squared, right? So we look at our original equation, and I'm only going to examine this piece here, x squared plus 10x, right? Well, what do I have? I have x squared, which corresponds to my a squared. I have this middle piece, which is 10x. So this entire thing here corresponds to this middle piece, 10x. And now how does 10x really compare to 2 times a times b? Well, we know that a is going to be x, right? And we know that because we have x squared corresponding to our a squared, right? So we know a is x. A is equal to x, according to, setting it into our blueprint. And now we have this middle term of 2ab, right? And our middle term over here was 10x. So 2ab is equal to 10x. And solving, we're trying to solve for b, right? Because b is the last unknown that we have to really figure out. So solving for b, we divide over 2a. And again, a is really x, right? That's what we just figured out before. A is equal to x. So we're going to divide by 2x on both sides. Dividing by 2x, x divided by x, these would cancel out. 10 divided by 2 just leaves us with 5. So b is equal to 5, right? And the last thing that you have to consider is this square, right? That's where this is coming from. And the reason that this square is coming from is right here, this term, the plus b squared. And when you're looking at x squared plus 10x, you realize all we're really missing is b squared. That's what we've been missing the entire time. So to get b squared, we use that tool, b over 2 squared. And that's how we figured out what piece we were missing in general. That's how we figured out that we needed the plus 25. So, for example, if this were x squared minus 10x, then instead of you corresponding it to the a plus b squared, what you would actually end up with is you would end up with 2 different x minus 5 factors. So if we had, for example, and I'll just write this out, if we had x squared minus 10x plus 8 is equal to 0, we would end up with a very similar scenario where we had the square root of 17, right, all on the right side, so square root of 17 plus or minus, but the difference is that we would end up with x minus 5 squared, which again corresponds back to this guy here, a minus b squared. Okay, I know that was a lot of talking, and if you didn't understand that, if you didn't understand why this was derived the way it was, that's okay. I'm not testing you on where it's derived from. All that I expect you to know is if you're going to complete the square, you have to be able to use this tool properly, the b over 2 squared. And again, all you're doing is you're taking your middle term, dividing it by 2, squaring it, so that way you don't have to worry about, plus or minus. You're always going to get a positive number. And then you're adding that number into both sides of your equations, and then you're just going to try to factor from there. Okay, let's look at another example. But in this example, our coefficient to x squared, our a, is not going to be 1. And we're going to see how this plays out. So we have 3x squared minus 4x minus 1 is equal to 0. And we say to ourselves, okay, well, again, our coefficient to x squared is not 1. What do we do? Okay, when your coefficient to x squared is not 1, you have to do a step before you do the b over 2 squared. The step that you have to do is you have to divide every single term, so both sides, right, and every term of both sides, by whatever your coefficient is. So in this case, our coefficient is 3 for our x squared, right? So that means I have to divide every single piece of both sides by 3. The reason is because we only want to deal with 1x squared. So now 3 divided by 3, great, that's going to cancel out. We're left with an x squared here. We get 4/3 x minus 1/3, right? 1 divided by 3 is just 1/3. We keep the sign the same with a negative, right? And we know that 0 divided by 3 is still just 0. And we say, okay, great. We're doing okay. Sure, we have fractions. Sure, it's going to look gross in the end because we have fractions, but that's okay because we've now cleared the coefficient tied to our x squared. So now what do we have to do? Well, now we just go back to our b over 2 squared, right? Okay, what is b in this sense? B is going to be the negative 4/3, right? It's going to be my coefficient to whatever my x to the first power is. So we're going to plug that in. We get, and I'm going to draw bigger parentheses here because we're going to need it, negative 4/3 all divided by 2 squared. And if you can't do this in your head, like if you're unsure on how to approach this, then what you have to do is you say, well, 2 is really the same thing as 2 over 1, right? And now we have a fraction divided by a fraction. We can do this, right? This is just keep, change, flip when we have a complex fraction. So making it into keep, change, flip, we get negative 4/3 times. And what is the whole point of keep, change, flip? We keep the first fraction, we change the division to a multiplication, we flip the last fraction. So instead of 2 over 1, it is now 1 over 2, or 1/2. Still being squared, right? Okay. So now we have 4/3, negative 4/3 times 1/2. If you can't see this immediately, then just multiply across like you would for normal fractions, and you would get negative 4/6. But I can see that our 2 here is going to cancel with our 4 up top, and it's just going to leave us with a 2, right? And that means that we're going to end up with a negative 2/3 squared. Again, if you didn't see that, that's okay. You just multiply across, you would get negative 4/6, and then you would just have to say, well, negative 4/6 is, simplifies down to negative 2/3. Okay? And now for a fraction raised to an exponent, you just apply that exponent to each individual component, so the numerator and the denominator, and our our negative is of course going to go away because it's being squared, right? So 2 squared is the same thing as 4, 3 squared is the same thing as 9, and it's positive. So great, we now have our b over 2 squared. We figured it out. And what do? Same thing that we did before, right? We're going to go ahead and add it into both sides of our equation. So we get x squared minus 4/3 x, sorry, I meant to write this all in black. Okay, x squared minus 4/3 x plus, and now we're getting that 4 over 9 that we solved for originally, right? We're adding it in. And now whatever we do to one side, we also have to do to the other, right? So we still have that minus 1/3 is equal to 4/9. And I'm going to also write this again in green because, again, what this is as a result of our b over 2 squared. Okay, so now what we're doing is we're just considering this piece here, right? Because now we added this number in the 4/9 so that we could factor, right? So negative 1/3, well, what is negative 1/3? Well, negative 1/3, I just want to add to the other side because we don't need it anymore, right? So now we have x squared minus 4 over 3x plus 4 over 9. And adding 1/3 to the other side is equal to 4/9 plus 1/3. But we have a denominator of 9, so to add fractions, we need to make it, the same fraction. So we get 4/9. We have same denominator. So we have 4/9 dropping down. Adding 1/3 to it is the same thing as adding 3/9, right? You agree with me? All I did was multiply top and bottom of the fraction by 3. So now we have 3/9. We have the same denominator. And when I combine them, I'm just adding the numerators and we get 7/9, right? So I'm just going to do that now in one step and say, great, this is 7/9. Okay, we're doing good. Now all we have left to do is just factor this. But factoring this, even though it's fractions, is actually going to be relatively easy. The reason that it's going to be easy is because now all you have to think of is, well, this piece should, in theory, if we did this correctly, it's going to come out to be in the form of a minus b squared. Because that's the whole point of adding the 4/9. We're either going to get a minus b squared or we're going to get a plus b squared. And the only difference between the two is going to be the sign of our middle term. So because our sign is a negative, we know that we're talking about this guy. So that means that we know that we're going to factor to be an a minus b squared. So because it's a minus b squared, well, what's my a? My a is x, right? That's our a squared. So that means a is just x. So we're going to have a minus b squared. So we have x minus, and now we just have to figure out what b is. Well, by process of elimination, you can do it in one of two ways. You can either look at your middle term or you can look at your last term. If you're looking at your middle term, we're looking at negative 4/3 x, right? But what do we know about a minus b squared? Well, a minus b squared, when it's expanded, which is what we have here, we have the expanded version, right? We're trying to go backwards. When it's expanded, it's in the form of a squared minus 2ab plus b squared. So if our middle piece is minus 4/3 x, this is the same thing as the minus 2ab, right? It's this middle term here. So obviously we can get rid of the negatives because negatives on both sides. We're going to just multiply by -1 or divide by -1, however you want to think about it. Well, we already talked about that a is x. So I can really just substitute, instead of a, I can put an x here. And again, our entire idea is we're just solving for b, right? So I'm just going to divide both sides by 2x. And we get b is equal to dividing by 2x. Well, when I divide x on both sides, our x's are going to cancel out, and we get 4/3 divided by 2, but we know that, right? Didn't we just do that? What is 4/3 divided by 2? It's, here it was negative 4/3, but 4/3 divided by 2 is just 2/3, right? So we get b being 2/3. And now we see that a minus b is just x minus 2/3, right? So that was one way to think about it. Another way is you could have just considered your last term, which is 4/9. So 4/9, and just erasing this. And again, what we're looking at now is just the b squared term, 4/9. And this is probably the easier way to think about it. Well, if we're just, this is b squared. If we're just trying to get b, then just square root it, right? Square root, b is equal to 2/3. Because when you take the square root of a fraction, you are just taking the square root of each, the numerator and the denominator. Square root of 4 is 2, square root of 9 is 3. Great, 2/3. So now we know x minus 2/3. And the reason that you don't have to put plus or minus here is because we're plugging b into our blueprint. We already know what the sign is going to be. The sign is supposed to be negative. So you don't have to worry about, plus or minus here because we know that it's supposed to be x minus 2/3 squared. Okay, so we get x minus 2/3 squared. This is equal to 7/9. But now we see, oh, we have a quantity being squared is equal to some constant. We can apply the, the considering the squares method, right? We can apply the squares method, which means that all I have to do at this point is take the square root of both sides. Taking the square root of both sides means that I'm going to cancel my exponent with the square root here. We get x minus 2/3 is equal to, okay, I'm going to apply the square root to the top and the bottom of my fraction. Square root of 7 isn't going to cancel with anything, right? Square root of 7 is just square root of 7. But we know that the square root of 9 is going to be 3, right? And remember what I told you guys, when you're solving for a variable here, you're taking the square root, we're solving for x plus or minus, right? So we get a plus or minus of the fraction square root of 7 over 3. Okay, the reason that I took the square root of 9, the reason that I distributed is because I wanted the same denominator here as I do here, because what's my last step? I'm going to add 2/3 so that I can solve for x. So adding 2/3, we get 2/3 plus or minus square root of 7 over 3. And what do we know about adding or subtracting fractions? Well, as long as they have the same denominator, we can just add the numerators, right? Or subtract the numerators. So our final solutions are going to be 2 plus or minus square root of 7 all over 3. And we are done. And that's it, right? We ended up with two solutions. One solution is 2 plus square root of 7 over 3. The other solution is 2 minus square root of 7 all over 3. So we're done. That's it. So again, let's recap, right? Let's go through the process that we took. The first step that we took was we evaluated that x squared had a coefficient that was not 1. So because it was not 1, we had to divide out that coefficient. So we divide out the coefficient to every single term, both on the left and on the right. We get an x squared minus 4/3 x minus 1/3 is equal to 0. Now, because we have a 1x squared, we can now apply our b over 2 squared tool, which is what we needed. We know that our b, in this case, was negative 4/3. So we applied negative 4/3 divided by 2 squared, right? So negative 4/3 divided by 2 squared. We, went through some keep, change, flip stuff. We did the square. We ended up with 4/9. So now all we have to do is the same process as we did with the first example. You add 4/9 to both sides, which is exactly what we did here. We had that negative 1/3 part of the original problem, so we move that over to the right side. We had 4/9 plus 1/3 gave us 7/9. And now all we have left to do is to factor these fractions, right? And I understand that this might be difficult, but when you keep in mind what you're supposed to get with completing the square, you're always supposed to get either a minus b squared, or you're always supposed to get a plus b squared, and the only difference is going to be dependent on the sign of your middle term. You're doing completing the square with the idea that you're factoring to one of these two things. So with that in mind, we knew that we wanted a minus b squared because our middle term was negative. So we ended up just basically saying, well, b, by process of elimination, by doing a little figuring out, b had to be 2/3, right? So we get x minus 2/3 squared, which fits into exactly what we wanted, the a minus b squared. We have x minus 2/3 squared is equal to whatever our constant was on the other side, which in this case was 7/9. And now this goes back to what we learned in our last lecture, which is you take the square root of both sides, you keep, plus or minus on one side, and you solve for your variable x, and we get our two solutions. Okay, I know that was a mouthful. I know that was a lot to take in, but it's really not so bad once you start actually doing it on your own. So I want to give you guys the opportunity. Go ahead and try your first classwork assignment. It's 4x squared minus, let's see, 24x plus 25 is equal to 0. Go ahead, try this out. I can imagine that it's going to be a little bit painful, but try, see where you get stuck, and then come back to the video and see, if you, for help or to check your answers. Okay, so hopefully that didn't go terribly. So let's go ahead and do this one step at a time. Our first step, right? First step is we look at our coefficient of our x squared. Our coefficient is not 1, it is a 4, right? So we have to divide every single piece by 4. We do so, divide every piece by 4. Okay, so now these are going to cancel out, which is exactly what we wanted, and we just get an x squared. 24 divided by 4, 4 actually goes evenly into it, right? So we get minus 6x. And unfortunately, it's not a dream world, right? We still end up with a fraction, 25 divided by 4. There's nothing we can do there to simplify that. But 0 divided by 4 is always going to be 0. Okay, great. We've gotten rid of the 4x squared. It's now just x squared. We are now off to our tool, right? Our b over 2 squared. What is b? B is -6, right? B is going to be our middle piece, -6. So we have -6 squared. Right, I'm sorry, -6 over 2 squared. This is the same thing as -3 squared. And -3 squared is the same thing as 3 squared because negatives will cancel out. We just get 9. Okay, cool. So now we're going to add 9 to both sides. So adding 9 to both sides, we get x squared minus 6x plus 9, right? Plus 9 here. Okay. And we still have that plus 25 over 4 business that we couldn't really escape from. And I'm going to have a plus 9 on the other side, right? But thinking ahead, because I like doing that, I like to think, a couple steps ahead, which is something that you might get in the habit of as well. We know that eventually we're going to be moving over that 25/4, right? That's probably going to be our next step. So instead of putting a positive 9, what I'm going to put is a 36 over 4, right? And how did I get that? Well, 9 over 1, I want it to be in terms of fourths, because when I move over that 25/4, I want things to be able to cancel. So I am changing the appearance of it by multiplying top and bottom by 4, and that's 36/4. Okay, so hopefully that's all good with you guys. So now we have 36/4 on the right side, which is the same thing as adding 9. Okay. So now we have x squared minus 6x plus 9. I'm going to move that 25/4 over by subtracting. So essentially, when we have the same denominator of a fraction of two fractions being subtracted, all we have to do is subtract the numerator, right? So moving the 25/4 over, this is the same thing as 36/4 minus 25/4, which is just 36 minus 25. And now hopefully you guys can see 36 minus 25 is just 11. So this is just 11 over 4 on the right-hand side. Well, perfect. Now we just have this x squared minus 6x plus 9, and we know it's going to be in the form of a minus b squared. Why is it minus? Because we have the minus sign here, right? So when we factor this, we know that we're going to get x minus 3 squared. Where am I getting this 3 from? Well, 3 is coming from this 9, right? Because this 9 is technically b squared. So if I take the square root of it, we know that we're going to just end up with a 3, and that is equal to b, right? So we have x minus 3 squared is equal to 11 over 4. And now this part we can all do at this point because we're coming from that last lecture, right? So all I'm doing is I'm going to take the square root of both sides. We know that this is going to cancel with that. We get x minus 3 is equal to, and again, what I'm going to do is, obviously, you have the plus or minus, can't forget that. I'm going to apply the square root to both my numerator and my denominator separately. We can't break down square root of 11 any further, so that's still just square root of 11. But square root of 4, we know, is just 2, right? So we get plus or minus square root of 11 over 2. We're almost done. We just have to add 3 to both sides. We get x is equal to 3 plus or minus square root of 11 over 2. And if you really want to get fancy, for the record, I would accept this exactly how it is. But if you really want to get fancy and, combine the integer with the fraction, even better, because it definitely makes it look a little bit nicer. So we would end up with 3 is the same thing as 6 over 2. So we would get 6 plus or minus square root of 11 all over 2. And this would be your final answer. Again, if you stopped at this point, which is x is equal to 3 plus or minus square root of 11 over 2, totally acceptable, wouldn't take any points off. It's just that this is technically, if you were to look in your textbooks, they're probably going to leave it as this one here. So just keep that in mind. Okay, so that's it for completing the square. We're going to move on now to the end-all be-all, our big bad boy, the quadratic formula. So what is the quadratic formula? Well, it's probably best served to show you the quadratic formula instead of trying to define it, because the derivation for the quadratic formula involves taking your standard form quadratic. So again, standard form is ax squared plus bx plus c is equal to 0. And what people did to figure out what to do is they essentially completed the square, but for all of these variables. So they did, b over 2 squared, they added it to both sides, and, they solved for x. We're not going to do that because, again, derivation, unfortunately, is not the biggest part of this class. So don't worry about that. I'm not going to, quiz you guys on that. So what is the quadratic formula? Once again, there's no better way for me to tell you this other than you just have to memorize it. And unfortunately, although this is an all-powerful tool, it does come at a cost in that it is slightly annoying to memorize. Once you use it enough, though, it should stick to your memory, but it's just committing it there takes time. So the quadratic formula is as follows. We get x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and this is all divided by 2 times a. What are my letters A, B, and C? Where is this coming from? Once again, I told you it came from the standard form, right? So ax squared plus bx plus c is equal to 0. So your b is coming right here. Your b is also going right there, right? Your a and your c go underneath the square root as well, and then your a shows up one more time in the denominator. So your quadratic formula is this bad boy right here. And unfortunately, once again, it's a pain. I know when I was learning it, it was a pain, but it's just one of those things that eventually when you do it enough times, you commit it to memory. And luckily for you guys, this course is an online course. So you do have, you do have your notes and also technically the internet at your disposal, which I can't stop you from using. So if you ever forget the quadratic formula, just Googling quadratic formula will absolutely pull this up. Okay. So just try to commit this to memory, though, because I promise you this will show up in at least pre-calc. You may not need it for, calculus and whatnot, but if you go on and take pre-calc, this will show up, guaranteed, 100%. Okay, so how do we apply this? What is this doing? And also, I just want to take a second before we move on to an example. Notice it has built into it the plus minus, right? What is this telling us? This is telling us we should get, at most, two different solutions. We should get two solutions based on whether or not negative b is added to the square root of b squared minus 4ac, or subtracting the square root b squared minus 4ac. Okay? All right. So let's go ahead and let's try to apply this to an example, right? So we had x minus 3. Let's look at this one. X minus 3 squared is equal to 4. This example is actually an example that was in the last lecture. And if I recall correctly, I'm just spitballing off the top of my head, I believe our solutions came out to be 1 and 5 for this, right? What did we do for this? Well, and I'm going to write this in blue ink because this is what we did before. We took the square root of both sides, right? We ended up with an x minus 3 is equal to plus or minus 2. And then we solved for x, right? And then it gave us two different solutions. Also, alternatively, what we did was we, moved the 4 over and we did difference of squares. So either way, you ended up with, I think, 1 and 5 as your solutions. So now what we're going to do instead is we're going to put this into standard form. We're going to expand this and get it into this form here. Because once we get it into that form there, we can then plug it into our quadratic formula. So let's go ahead and expand this. We know that we have a minus b squared, right? So we should end up with a squared minus 2ab plus b squared. So we get x squared minus 2 times a, which is x, times b, which is 3, and then plus b squared, which is 3 squared, which is 9, right? Is equal to 4. Standard form means I'm going to pull that 4 over because we need a 0 on the other side. So we get x squared, and then negative 2 times 3 is minus 6x. And then subtracting the 4 from both sides, we get plus 5 is equal to 0. Great. Okay, we have it in standard form, right? With my a being, well, if it's hiding, it must be 1. My b is going to be negative 6. And my c is going to be positive 5, right? So we now just have to plug it in to this equation here. Negative b plus or minus square root of b squared minus 4ac, quantity, like the entire quantity, divided by 2 times a. And if also, as a tip for you guys, when you have 2 times a, I strongly recommend not actually multiplying out the 2 times the a, especially, when you have a coefficient of x squared, which isn't 1. Because again, that's your a, right? So if you had 2x squared, for example, you would end up with a 2 times 2 on the bottom. I strongly recommend not multiplying that out until the very end, because what you will find out that happens somewhat frequently is that factor of 2 will actually sometimes cancel with things that are above it, okay? So we might see that in this case, we might not, we'll just have to find out. So let's rewrite this, but this time we're going to be plugging into our formula. So x is equal to, first thing is negative b, right? So we write the negative, but b is also a negative 6, right? So we have negative 6, plus or minus. B squared is negative 6 squared. And then what do we have? We have minus 4 times a times c. So minus 4 times a is 1, right? That's our coefficient of x squared. C is going to be positive 5, so times 5. And this is all going to be over 2 times 1 because it's 2 times a, but in this case, 2 times 1 is still just 2. Okay, let's go ahead and simplify some stuff down. So negative 6. Well, we know 2 negatives are going to cancel. We're just going to end up with a positive 6 here. We get plus or minus square root of, what is negative 6 squared? It's the same thing as 6 squared, so 36, minus 4 times 1, which is 4, negative 4, times 5, which is negative 20, right? So 36 minus 20, this is all over 2. Okay, let's keep moving. X is equal to 6 plus or minus 36 minus 20 gives me 16, right? And this is now all over 2. And then the best part is when we take the square root of 16, we don't have to worry about the plus or minus like I've been trying to drill into you guys because it's built into our formula. So it's already there. It's perfect. We don't have to worry about it now. So we now have 6 plus or minus square root of 16 is just 4. So 6 plus or minus 4 all over 2. And now this leads us to 2 different solutions, right? Where either 6 is added to 4 or we have 6 minus 4. So we get 6 plus 4 over 2. I'm just going to put a comma, 6 minus 4 over 2, and this is 10 over 2, this is 2 over 2, and we finally arrive at our destination here, which is our solution set being 5, because 10 divided by 2 is 5, 2 divided by 2 is 1. And although it took a lot more work, right? This was definitely a lot more painful than doing, just taking the square root of both sides and then solving for x. What you have to realize is that we couldn't factor that in its current form, right? We couldn't do anything with that. And as a result, our factoring method was out the window. Well, what happens if the square root method is also out the window? Well, that's where the quadratic formula really comes to life. That's where we have this because we have a method of solving for any quadratic equation. Okay, so after all is said and done, all you're really doing for the quadratic formula is you're just plugging in. You're just plugging in numbers correctly. That's really the hardest part, is plugging in. The mathematical computation isn't really so bad, right? What did we see here? What did we have to really compute? Well, we had to realize that a double negative is a positive. We had to realize that negative 6 squared is the same thing as 6 squared, which is 36. And then we just had to do some light multiplication. 4 times 5 is 20. Go ahead and do some subtraction. Another, you take the square root, you add again, add or subtract, one more division, and you're done, right? So yeah, it's a long process, but it's a long process of things that you already know how to do. So don't be totally nervous or taken aback when you see the quadratic formula. It looks super imposing when you see this behemoth right here, but it's really not so bad when you just start plugging numbers in. Let's look at another example together, and this time I'm actually going to erase this because I want to see if we can, figure it out together without looking at it, just in front of us, right? So we already looked at x squared plus 10x plus 8 is equal to 0. We did this was our first example earlier today when we were talking about completing the square, right? So we're going to solve the same quadratic equation again, but this time we're going to do it using the quadratic formula. So what is my a? And this time I'm going to do it with different colors, right? A is going to be 1, right? B is going to be my 10, and C is going to be my positive 8, right? And I really should have specified, I'm sorry, that this is a positive 1, this is a positive 10, right? A plus 10, and C is a positive 8. So we have no negatives right now. Okay, let's go ahead and plug into our equation, our formula, right? So we have x is equal to, and now we have to start with the numerator, right? So we know for our numerator, we're going to start with negative b. Well, we have negative of a positive 10, which just means we have a negative 10, right? Next up, we have the plus or the minus. Then we have the square root of b squared, which is 10. Oh, I don't know why I put 11. Sorry about that. 10 squared minus 4 times a times c. So minus 4 times a, which in this case is still positive 1, times c, which is positive 8, right? So 4 times a times c, okay? And this is all over 2 times a, which is 2 times 1, which is still just 2. Great, we've plugged in. Now all we have left to do is just do the little computational steps and we'll be done. We will have our 2 solutions. So this is equal to, our negative 10 isn't changing, it still is just negative 10, right? Plus or minus, okay. 10 squared, 10 times 10, this is 100, minus 4 times 1 is 4, 4 times 8 is 32, right? 4 times 8 is 32. Okay, so we keep moving along, right? And this is all over 2. All right, We get negative 10 plus or minus. What is 100 minus 32? 100 minus 32 is going to be 68. I don't know why I needed that. There we go. So 68, right? This is still all divided by 2. Okay, now we have to do that annoying step, but it's a step that we learned how to do in, I think it was lecture 5 or lecture 6, something like that, where all we were doing was we have a square root of some number, right? And what we're trying to do is we're trying to break this up into 2 pieces where one of them is going to be a perfect square, right? Because we want the perfect square to cancel with the square root. So if you don't see it immediately, totally fine, right? Let's just start easy. We know that this is divisible by 2. So again, if you don't see it immediately, just take the 2 out. Let's see what happens. So 2 times what gives us 68? Well, that should be 34, right? So 34 times 2. Okay, great. Well, there's also another 2 because 34 is even, right? So we can take another 2 out. So this is now the same thing as 17 times 2 times 2, but this is really 17 times 4. Okay, great. We're done, right? We have factors for 68 such that one of them is a perfect square, and our perfect square in this case is 4. Okay, fantastic. So now when we take this the perfect square, we split it up. This is square root of 4 times the square root of 17. Remember, you box off individually the one that you can do something with and the one that you can't do anything with. Square root of 17, 17 is a prime number. We're just done with that. And square root of 4 is just going to give us 2 times square root of 17. Fantastic. So now we've simplified this, and this is minus 10 plus or minus 2 square root of 17 all over 2. And now what you say to yourself is, oh, I have an even number on the left, right? I have a negative 10, and I have another even number. I have 2 times square root of 17. So my 2 in the divisor is going to cancel out with all of these guys, and I'm just left with the negative 5 here. So what am I really left with? Negative 5 plus or minus square root of 17, which, if I recall correctly, is exactly what we had before. It just, again, took us a little longer to get there because before we completed the square, whereas now we use the quadratic formula, and we are done, right? X is equal to negative 5 either plus square root of 17, and then we also have our other solution of negative 5 minus square root of 17. So we're done. Okay. So I want you guys to go ahead and try your second classwork assignment now, and I want you to try to solve this quadratic equation using the quadratic formula. So the equation is as follows. We have 6x squared minus x minus 2 is equal to 0. Go ahead, give yourself a little bit of time, see if it clicks. Again, all you're really doing is just plugging in, right? But you have to plug in correctly, otherwise it's not going to work. So give yourself a couple minutes, see what you come up with. Okay, so hopefully it was all good. Let's go ahead and do it together. X is equal to, so first thing, right, numerator, we have negative b. Well, what is my b? My b is going to be this guy right here, the coefficient of x. What is the coefficient of x? Be very careful. It's not just 1, it is negative 1. Okay, the sign before the coefficient matters. So it is negative 1. So our very first thing is we have a negative of a negative 1. Okay, negative b, remember, so if b is negative 1, we have negative 1. Okay, now we get the plus or minus. We get b squared minus 4ac, right? So b squared is going to be 1 minus, and then we have, and well, technically it's negative 1 squared. I skipped a step, I'm sorry. Negative 1 squared is the same thing as 1 squared, and we know that 1 squared is just 1, right? Okay, 1 minus 4 times a times c, right? But what is, or what are a and c? Well, a is 6, right? That's my a, it's a positive 6. So we get 1 minus 4 times positive 6, and then we have a negative 2, right? So we get a negative 2 in for our c value right here. Okay, And now this is all over 2 times a, which is 2 times 6. And once again, I'm giving you the tip, don't multiply out the 2 times 6 until the very end when you're sure that nothing is going to cancel with that 2. Okay? Because if you can cancel, obviously I want you to cancel to make it as simple as possible. So what do we get? We get x is equal to, we get negative negative 1, double negatives. These are going to cancel. So we just get a positive 1 plus or minus 1. Okay, so we have 1 minus 4 times 6 is 24, right? So we have a negative 24 times a negative 2. So we know it's going to be positive, right? Because a negative times a negative. So we have 24 times 2, which is 48. Okay, this is now all over 2 times 6. And now 1 plus 48 inside the radical is super easy, right? We get x is equal to 1 plus or minus, we get square root of 1 plus 48 is 49, and we can do this, right? So that's 2 times 6 on the bottom. X is equal to, and now we have square root of 49 is 7. We already have that plus or minus, so we don't need to do it again. So we have 1 plus or minus 7 all over 2 times 6, right? And this we know is going to give us two different solutions. So we have 1 plus 7 all over 2 times 6, and then 1 minus 7 all over 2 times 6. And finally, we get 8 over 2 times 6 and negative 6 over 2 times 6. And now this is why I told you don't do the multiplication in the bottom, because what do we see happening? Well, our 2 is going to cancel with our 8 and leave us with a 4 up top. And our 6 is going to cancel with our 6 up here and just leave us with a negative 1 up top, right? So what we are actually left with is 4 over 6, which is 2/3, right? We can do that in our heads. So we get 2/3 here and negative 1/2. And this is our solution set. And we're done. And now we realize, okay, yeah, this took, quite a lot of steps, but this is definitely a lot easier than trying to factor something where our coefficient of x squared is 6. Why? Because what would we have to do? Well, we would have to go, okay, well, 6x squared. If you were going to try to factor this, we'd have to be like, okay, 6 our a times c step, which is 6 times negative 2. Okay, this would give us a negative 12. Okay, negative 12, we have to find out such that it gives us a negative 1. So it would be negative 4, positive 3. And then you'd have to go into your grouping steps, right? So this is one where things actually worked out really well, but that's not always going to be the case. Okay, so I'm just warning you now that it will get ugly, and you have to be prepared for that your quadratic formula is going to start giving you some really gross answers that actually will be correct, assuming you plugged in correctly. Okay, all right, there's one last topic that I want to talk about today before I end this video. I know I think I'm pretty close to an hour, if I'm not already at an hour, so I apologize. This one last topic that I want to talk about is considering the complex or imaginary values. Where are our complex and imaginary values coming out of? Well, remember we have from our quadratic formula minus b plus or minus b squared minus 4ac all over 2a. Okay, if we have a situation where 4 times a times c is a larger number than b squared, we would end up with a negative number, right? Because we'd have a smaller number, and I'm talking about this here, right here. We'd have a smaller number minus a larger number, which means we would get a negative number. And then we would have a negative number underneath a square root. And as we already talked about, that's not defined for real values, right? Let's look at a quick example to see when this actually happens. So let's consider a really easy basic one, right? And again, I really want to reiterate, you are not being quizzed on this. I just want to show you guys what happens when this occurs, okay? So say we have x squared plus 1 is equal to 0. Now, we already discussed a little bit before that we can't actually factor this. And the reason we can't factor this is because you might be inclined to say, well, this is difference of squares, right? Because 1 is just 1 squared. But it's not, because we don't have a difference. We have an addition. We have 2 squares, but they're being added together. So we can't factor it into a plus b times a minus b. So this is not a difference of squares, right? Okay, so let's intuitively try to think about what this is actually going to look like for different values of x squared, right? So let's say I build a little table here where I have my table of x, and we want to see what the output is for x squared, right? So I'm going to start from -2. So if I have -2, I have x squared, which would make it 4, right? Because -2 squared makes it 4. Okay. -1, -1 squared is 1. Okay. 0, well, 0 squared is still just 0. All right, let's go to the positives now. 1, well, we're going to get a reflection, right? We're going to get the same thing back that we had for the negatives, because what does a square do? It's essentially going to multiply it against itself, but it's going to always make it positive. So 1 squared is +1, and 2 squared is 4, right? And as you can see, as we get larger and larger numbers, whether they're negative or positive, so say we went on to 3, we would get 9 here, right? X squared is going to always get larger and larger and larger. So when is x squared at its lowest value? X squared is at its lowest value right here, right when x is equal to 0, right? So let's say, hypothetically, let's talk about when x squared is at its lowest possible value. Well, when it's at its lowest possible value, we have a 0 here because, you know, if x is 0, then x squared is 0. We get a 0 plus 1 is equal to 0. And then we say, well, wait, 1 is equal to 0. This makes no sense. We're obviously doing something wrong here. Well, you're not. The thing is that x squared plus 1 has no solutions in the real numbers, okay? What am I talking about when I say in the real numbers? Well, let's try to solve it a different way. Remember what we did when we had when we were considering squares, right? Our other way was to brute force it, see what operations were attached to our x, and just try to undo those operations, right? Okay, well, let's move the 1 over to the other side. We have x squared is equal to -1. Well, I'm going to take the square root of both sides. So taking the square root, we have x, right? Because what happens? That cancels. We just have x. We know we're going to have the positive or negative, but we have plus or minus the square root of a -1. And we know that the square roots aren't defined for real numbers for a negative value. But what did I tell you guys was the case in lecture 4? This right here, this piece, is what we call an imaginary number. In fact, this is the base case of an imaginary number. This square root of -1 is really called I. That's what we denote it as. So our solutions are x is equal to positive plus or minus I. And what this means is these are solutions that are found in the complex world. They exist beyond the real numbers, beyond our scope of what we're talking about, okay? So why am I bringing this up? Well, this is obviously not the only time that this is going to occur. This x squared, plus 1 here. X squared plus 1 is equal to 0, sorry. There's actually an infinite amount of quadratic equations where you're just not going to have real number solutions, but you will have complex solutions. And now what I really want to point out to you guys is just because you have complex solutions does not mean what I said to you earlier was a lie about the square implying the maximum number of solutions that you get. Why am I saying this? Well, remember what our solutions came out to be. It came out to be x is equal to plus or minus I, right? Which means we actually do still have two solutions. We have positive I and we have negative I. It's just things that we don't necessarily care about for the purpose of this class. It's way outside of our scope, okay? But just keep in mind that we still end up with two solutions, which is in line with what I've been trying to tell you all along. Just because they don't exist in the real numbers does not mean we don't get two solutions. Okay? All right. So one example of how this applies for the quadratic formula, let's go ahead and look at this following equation. We have 4x squared minus 4x plus 3 is equal to 0. Now, there's really no way of knowing that this won't work for you until you really start going, right? So let's plug it into our formula. We have negative b, so we have negative of -4, right? B is this guy here. So -4 plus or minus the square root of b squared is -4 squared, which is the same thing as 4 squared, which is 16, right? So -4 b squared, Okay, so we get 16 minus 4 times a times c. So a is 4, so we have 4 times 4 times c, which is a positive 3, right? Okay, this is all over 2 times a, and a, once again, is going to be 4. For the purpose of this example, our denominator actually really doesn't matter, but I'm going to solve it all the way through just to really show you guys and illustrate what's going on here, okay? So we get x is equal to, well, double negatives cancel, we know that. We get 4 plus or minus, and now this is where things start getting tricky. We have 16 minus, well, we already know that the right number is going to be bigger. Why do we know that? Because 4 times 4 is already 16, and we haven't even multiplied the 3 yet. So obviously, we're going to have a problem here. So 4 times 4 is 16, times 3 is 48. Okay, we get 48 all over 2. I keep writing 2a, I apologize. 2 times 4. Okay, we keep going. 4 plus or minus. Okay, 16 minus 48 is a negative 32. This is still all over 2 times 4. Now, here's the important part. This is really the part that I wanted to illustrate. Remember what I told you guys about if you have some numbers, right, being multiplied together, we can always split them up into their individual pieces, right? This is when they're underneath the square root and it's still being multiplied, right? Well, if we have square root of negative 32, this is really the same thing as positive 32 times negative 1, right? So what I'm going to do is I'm going to split them up into their each individual parts. So we have square root of 32 times square root of negative 1. And what did we just say square root of negative 1 is? This is our base value I, right? This is our imaginary number. So really, this is square root of 32I. Or you could put the I in front and say I times square root of 32. Doesn't matter. Okay. And we know that square root of 32 we can actually simplify because it's 4 times 8. 4 is a perfect square. So this is really 2 times square root of 8. And I'm going to put the I right here. 2I square root of 8. Again, this I is this piece here, the square root of negative 1. Okay, so what happens? Again, we simplify this, right? We get 4 plus or minus 2 times I times square root of 8. We can actually do a little better. I just realized, sorry, it's a little late that I'm doing this. So square root of 8 is also square root of 4 times 2. So this is 2 times I times square root of 4 times square root of 2. So square root of 4 is 2. 2 times 2, we get 4 times I times square root of 2. Sorry, my mistake. Again, a little late that I'm recording this, my mistake. Okay, so we're going to just clean this up. Call it 4I times square root of 2 all over 2 times 4. Okay, we're almost done. We have a 4 in the bottom. We also have a 4 in each piece up top, right? Which means that we can cancel out this 4 here, this 4 here, this 4 here. So what are we really left with? We are left with x is equal to 1 plus or minus I times square root of 2 all over 2. And what you'll see if you dive into this in pre-calc is they like to split up the imaginary part from the real part. So what do we know about fractions? We know that when they have the same denominator, we can just add or subtract the fractions together and keep the denominator the same. Well, we can also go backwards, right? So this is really the same thing as 1 over 2, keeping the denominator the same, right? Plus or minus I square root of 2 over 2. And this would be your final answer, right? X is equal to this, and you still have, keep this in mind, 2 solutions. Even though this is a complex number, you still have 2 solutions because you have the 1/2 plus the I squared root of 2 over 2 and the 1/2 minus I squared root of 2 over 2. Okay? I promise you that for the rest of this semester, we're never going to talk about this again. I know that it's really confusing for the first time that you see it. My heart goes out to you, I promise. But just according to the Oneonta curriculum, they want us to, really touch on this. So I'm preparing you that if you go on and take other math courses, you will eventually see complex numbers come back up again. This is just your first introduction to them, that a complex number is the square root of -1. Okay, so that's that. Okay, so really, what's the purpose of this? This is to show you that our solutions are not in the real numbers, which means that we would have no real solutions. And that's what you would end up writing here. You would not go through this entire process. Essentially, once you got to this step right here, where we have the negative 32 underneath the radical, you can stop right there and you can say, no answer, no solution. You can even do one better and make me very happy, and you can say it's the empty set. Because again, empty set implies there's no solutions, right? Okay, so that's it for the video, guys. I know this went, kind of long, and I know that I touched at the last, couple minutes on this example that talks about square root of -1 or square root of negative numbers being complex numbers. Again, you will not be quizzed on it in this course. If you forget it leaving my class, you forget it. And, so be it. I just have to tell you this now because when you go on to future math courses, I promise that this is not going to go away. It's just going to be one of those things that you will have to learn, or if you forget it from my class, that you will have to relearn. Okay? So otherwise, try the homework, see how far you get. Feel free to shoot me an email if it's, difficult, and we'll talk about it a little bit on Friday before your quiz. All right, guys, enjoy the rest of your day, night, whenever you're seeing this, and have a good one. Stay safe. See you later.